Let's start video. So here R, which
Sir,
is, yes,
so you made a statement. You said the complex number and its conjugate have the same modulus. That's what you did say?
yes, the complex number and its conjugate have the same modulus. So R, which is the modulus of Z, is equal to the square root of 2 square plus minus 1 square, which is equal to the square root of 4 plus 1, which is the square root of 5. Let's turn the page. All right, very quickly, do C and D. So here, the modulus of Z, or R, which is the modulus of Z, is equal to the square root of 3 square plus 4 square. This is the square root of 9 plus 16. This is the square root of 25. This is 5. Here, the modulus of Z is equal to the square root of the real part square, which is cos square theta, plus the imaginary part square, so that is sine square theta. Everybody should know by now that sine square theta plus cos square theta is 1, and the square root of 1 is 1. All right, any issues there?
No, sir. Just taking notes of
Yes.
what you said.
All right, everybody should remember from unit 1, sine square theta plus cos square theta is equal to 1. All right, now example 17. With example 17, you're asked to find both the modulus and the argument. Now, please note, because of the issue with the argument, how you calculate the argument depends on the quadrant. You have to be 100% certain of the quadrant you are in before you calculate, before you say, yes, you know what the argument is. So I'm doing B. So let's go for the modulus. So R, which is the modulus of Z, is equal to the square root of 1 square plus minus 1 square. So this is the square root of 1 plus 1. This is the square root of 2. So the modulus is the square root of 2. Next, I want to determine what is the argument. Now, before I try to determine what is the argument, I must first be clear on what quadrant this is in. Now, the point 1 minus 1, which quadrant is that? 1 minus 1, which quadrant is that?
The fourth quadrant.
This is the fourth quadrant. So because it's the fourth quadrant, the argument of Z, which is theta, is just equal to tan inverse the real part, which is minus 1 over the, it's the imaginary part at the top, please. Why is the imaginary part? Over the real part, which is positive 1. And the tan inverse of 1 is 45, which in radians is pi by 4. So the argument is, the modulus is root 2, and the argument is pi by 4. Please do A and C right now. This should have been minus 45. All right, so that's a correction. It should be minus 45. All right, everybody clear with that? Minus 45 meaning it is in the fourth quadrant. So here, the R, which is the modulus of Z, is the square root of 1 square plus 1 square, which is the square root of 2. 1, 1 is in the first quadrant, so the argument of Z, theta, is equal to tan inverse 1 over 1, which is 45 or pi by 4. C, let's have a go at C. There's a D as well. So minus 1, 1 is second quadrant. So the argument, the modulus, sorry, of Z is the square root of minus 1 square plus 1 square, which is still the square root of 2. Now, minus 1, 1 is the second quadrant. So the argument of Z is equal to pi plus tan inverse 1 over minus 1. Now, tan inverse 1 over minus 1 is going to give you minus pi by 4. So this is pi minus pi by 4. And this is equal to 3 pi by 4. Any problems with what I've just done? Let's do D. R is equal to the modulus of Z is the square root of minus 1 square plus minus 1 square. This is still the square root of 2. Now the argument of Z, now minus 1 is in the third quadrant. So the argument theta is equal to minus pi plus tan inverse minus 1 over minus 1. Minus 1 over minus 1 is the same as saying just positive 1. And the tan inverse of positive 1 is positive 45. So this is minus pi plus pi by 4, which is positive 45. The answer here is minus 3 pi by 4. All right, I'm going to stop the video here and then we're going to go to the next page.